Question 4 is another example on the workings for the instantaneous center question or how can you use the principle of instantaneous center to solve your problem. So over here, question 4 says that there's a vertical plate ABED is spin to the rod OA at the point A and is supported by a roller at E, which slides in a horizontal slot. In the positions shown, the velocity of E is 0.7 meter per second to the right. So determine the angular velocity of the plate and the velocities of A, B, D, and E okay? A, B, and D. So I'll expand out the diagram. Now, so how do I come about with this diagram? Firstly, I know that velocity of E is given to me. That's 0.7 meter to the right. So I know the vector is pointing this way. Hence, the perpendicular line should be along here. So there's a line that cuts this way. To form the intersect to find the instantaneous center, I need another vector to create the secondary line to form the intersect However, I'm using point A in this case because I know that point A is also rotating about point O. So the arrow is pointing either this way or pointing upwards. So it's along this line. So the vector is along this line. Okay, this would mean the perpendicular line would be along here. And with these two lines, I form an intersect, and that is the instantaneous center. The reason why I draw the arrow pointing down is because I know when point E goes towards the right, point A, there's no chance for it to go upwards, so it has to come down. So that's the only vector that's coming down over here. Okay, so with these two, you can find the instantaneous center. Ignore all these dotted lines that I've drawn. See over here and the blue and red. Just ignore that for now. Okay. So the first question they want us to find is what's the angular velocity of this plate. With the point IC and this velocity, you can very easily find the angular velocity because angular velocity along any point on this plate is the same about IC. So I know that the velocity of E is 0.7 meters to the right. Then I can use my vector cross product to find out what's the angular velocity. Now I can see that there's triangle over here and another triangle over here. So there's similar triangle properties that I can use over here. And why do I need that? It's because I do not know what is the length of DIC. I know what's DE. I know this length, but I do not know what is this length. Because in the vector cross product, I need to know the RE from IC. So I need to know this entire length. Meaning to say I need to know this length. So to know this length, I can use the properties of similar triangles. So there's this small triangle and a big triangle. So by similar triangles, I name this as this length over here. See this IC to this red line over here as 3 plus H. So 3 plus H Y over X 12 meter is equals to this Y, which is H, over X, which is 8 meter. That's why it's 3 plus H over 12 equals to H over 8. Over here, you just manipulate the equation and solve for H, and H will be 6 meters. So over here, this is 6 meters. Okay, very simple. You also need to find what's AIC . So if you know this is 8, this is 6, through Pythagoras theorem you can find what's AIC. So this is what I've done. I found out that AIC is 10 meters. And I know that VE is actually 0.7 meter per second towards the right. And then VE is equals to angular velocity crossed with the crossed with the displacement vector. Okay? The position vector actually. So omega E from IC crossed with RE from IC. E from IC. This is 6 meters, this is 8 meters, 6 plus 8 is 14. And the position vector is downwards because E is bottom of IC. E from IC is negative 14. So negative 14. I know VE is 0.7. So I do the vector cross product and can very easily solve for angular velocity of EIC. Again, assuming that the angular velocity is rotating in the positive direction. In this case, my assumption is correct and I got it to be 0.05 radian per second in the positive k direction. So that's the first part of the question. Next, I'm trying to find velocity of A. Very similarly, velocity of A is angular velocity of A from IC crossed with position vector of R from IC. Angular velocity A from IC is same as angular velocity E from IC, because like I said, angular velocity along this entire plate, any point along this plate about point IC has to be the same. Okay, so let me see. By doing the cross product, I realized that I lack of the position vector of A from IC. So A from IC, I've already done the values, as in the magnitude of A from IC, and that's 10 so I only lack the position, which is theta over here. So this theta over here is actually this theta over here. Okay, to find theta, I use arctangent of 6 over 8 and I'll get 36.87. so with that, I know my position vector of A from IC is 10 in this position. Why I add 180 degrees? Do know the angle is measured from the positive x-axis, hence I need to add 180 degrees plus the theta that I just calculated. That's why I have 180 plus 36.87. Okay, once I got the position vector of A from IC, I just bring this up here and do the cross product, and very simply I can find out what's the velocity of A, and that will be 0.5 in 306.87 degrees. And this is different from the answer that's given, where it says negative 53.13. But the thing is, 306.87 is the same as negative 53.13. Okay, because one revolution is 360 degrees. So imagine this vector over here. See this velocity vector. So when I measure from positive A, from positive x-axis, I can measure in an anti-clockwise direction, and that will give me about 300 plus degrees. Or I measure from counterclockwise, from the clockwise direction, and they'll give me negative direction. That's why this or this, both are the same answer okay. And then the way to find velocity of B and velocity of D is the same as finding velocity of A okay. So velocity of B is just angular velocity of B from IC crossed with position vector of B from IC. So angular velocity is the same, 0.05. Then to find position vector of RB from IC, B from IC, so I draw one line over here and I try to find this length. This length can be easily found through Pythagoras theorem, because I know what is this length, I know what is this length. This is 8 over here, this is also 8 plus 6, so this is 14. And then I also need to find theta 1, so this will be theta 1, theta 1. Okay, so I found that BIC is actually 16.125 through Pythagoras theorem, and then theta 1 is 60.255. Same as before, I had to add 180 degrees to this angle over here, because angle is always measured from the positive x-axis. So you add 180 degrees and theta 1. Okay, and then you can do the cross product, and I found out that my velocity of B is 0.806 in the 330 and 0.26 degrees direction, or 0.806 in negative 29.74 degree. Same thing. Lastly, find velocity of D. It will be angular velocity of D from IC crossed with position vector of D from IC. So I know what's angular velocity, I need to find what's the position vector D from IC. D from IC is just in the J direction, so it's negative 6, because I know this length is 6, so it's negative 6 in J direction. So when I do the cross product, when I put in the unknown or the known that I have, I do the cross product. 0.05 multiplied by negative 6 gives me negative 0.3. K cross with J gives me negative I, hence this gives me 0.3 in I direction, and that's the answer. This is same as this, 0.3 in 0 degree. So that's all for question 4, and yeah, using instantaneous center you can easily solve for this kind of questions.